When the universe chooses to communicate, it frequently does so through a photograph. That was my sentiment on November 11th, when a fresh batch of images landed on my desk, showcasing the remarkable 3-eye atlas as it emerged from its obscured position behind the sun, taken mere days after its perihelion passage. No longer concealed, the object unveiled complexities that deepened the enigma instead of clarifying it. Multiple jets fanned out like brilliant strands, each carving its own path through the solar wind. I noted during the Q&A I released that day that these jets do not behave as typical cometary outgassing would. Their configuration, intensity, and penetration through the solar wind all prompt further inquiries. For months, we've observed this interstellar visitor challenge our predictions. It accelerated inexplicably, shifted colors in a manner that defies cometary chemistry, and survived perihelion intact, exhibiting a jet system that is more intricate than any we've documented for a comet in our own solar system. This compelled me to write the Q&A because in the realm of science, as the image becomes clearer, the questions grown ever more unsettling. Let me clearly portray the new jet images, as they are extraordinary. At first glance, the telescope composite from November 11 reveals a luminous nucleus of 3-eye atlas encircled by white curved streaks that radiate outward in various directions. Some jets shoot out radially while others curve, and some seem to pierce the solar wind with force and precision, whereas others diffuse gently. However, one feature astonished me: several jets directed toward the sun. That alone defies the norms. Normally, comet outgassing occurs due to sunlight contacting the surface, resulting in jets that should be oriented away from the sun, not toward it. Yet here we observe jets aimed at the sun, jets bending at unusual angles, jets exhibiting high momentum despite drag, and jets whose brightness doesn't correspond with water vapor. In my Q&A, I stated, the jets observed on November 11 are powerful enough to penetrate the solar wind. For ice, this would necessitate an enormous mass being expelled. However, the object isn't substantial enough to yield that mass unless it has fragmented. The image serves as observational data. It isn't an illustration or simulation. The universe is crafting a map for us, and we must learn to interpret it. To comprehend these jets, we revisit basic principles. A jet signifies a force, which implies momentum. Momentum in turn necessitates mass and velocity. If 3-eye atlas is emitting mass through these jets, it must be shedding material at prodigious rates, far exceeding what its estimated size can accommodate. I derive this extensively in my Q&A. For a natural comet to generate jets capable of penetrating the solar wind, the expelled total mass would have to ascend to billions of tons. This leaves us with two possibilities. First, substantial fragmentation. The object may have disintegrated into a cloud of debris, each fragment increasing surface area and producing jets. This would permit more total area for sublimation, leading to greater mass loss and jet generation. This aligns with the count of jets. We've observed at least 7 prominent jets, possibly more. However, as the fragments would begin to drift apart, should we notice separation in the upcoming weeks, this hypothesis would gain traction. Second, propulsion akin to an engine or non-thermal jets. While this prospect is more contentious, it must be considered since the physics permits it. If these jets are not a result of sublimating ice, but arise from electromagnetic discharge, plasma ejection, internal heating, or deliberate propulsion, they could reach the observed speeds without requiring massive losses of material. As mentioned, in a technological context, jets need not expel 10% of the object's mass. Even a small mass fraction can enable significant acceleration if properly directed. This isn't mere speculation. It is a physics principle. A machine that expels a modest amount of material at high exhaust velocity can dramatically alter its motion. Today's jets manifest long, narrow, directional behavior reminiscent of propulsive plumes rather than diffuse cometary geysers. Still, nature has an uncanny way of surprising us. This is why the next few weeks will be critical. The November 11 image provides the clearest evidence thus far that 3-eye atlas does not conform to the typical comet profile. Let's examine what the structure indicates. First, the jets exhibit varying speeds. Some extend outwards significantly, while others barely part from the nucleus, suggesting differing speeds, mass densities, and ejection energies. Such variability is quite uncommon for a natural comet. Second, jets oriented toward the sun contradict classical thermodynamics. Sunlight is unable to propel material toward the sun. It can only heat it if the material flows sunward. This indicates that an alternate force is at play, perhaps magnetic fields, electric currents, internal energy, or a directed source. Third, the jets are leaving trails as they penetrate the solar wind. The solar wind represents a stream of charged particles emitted from the sun. Typically, cometary jets will bend, diffuse, or be blown outward. Yet, we see distinctly straight lines indicating potent momentum. Fourth, the possibility of fragmentation still exists. The November 11 image showcases a thick, opaque central plume that might overlap multiple bodies visually. If the object did fragment on October 29, as the physics strongly implies, each section could potentially generate its own jet. Conversely, if fragmentation did not occur, then the jet system we're witnessing is extraordinarily atypical and possibly intentional. Fifth, the outcome of the next few weeks will be decisive. As I noted in my Q&A, if 3I Atlas retains its cohesion and continues to emit high-speed jets, we must earnestly consider the potential technological implications. Nature has its rules, and 3I Atlas seems to enjoy bending them. Let's address the color. As in science, colors offer valuable insight. The blue-green hue in the November 11 image likely results from ionized nickel and diatomic carbon C2 excited by plasma interactions with the solar wind. This combination is exceedingly rare. Most comets in our solar system glow white from dust, red from hydrocarbons, or faint green from C2 molecules near perihelion. In contrast, 3I Atlas glows blue-green along with metallic lines and an ion tail, signaling that its chemistry diverges from the ordinary. The heating mechanisms in play are unusual. As while nickel appears to vaporize at significant distances from the sun, the object may possess metallic components. In my Q&A, I stressed that nickel sublimation necessitates internal heating or exotic ice, since its abundance does not align with solar system comets. This bolsters two crucial notions: that 3 Atlas is ancient, formed 79 billion years ago, and its composition could resemble industrial alloys. The color isn't just ornamental, it's physics revealing a narrative. One remarkable facet of the new image highlights how jets emerge from various angles, suggesting an asymmetrical, possibly elongated structure. If the object is flat, hollow, has ridges or vents, the jets would then angle asymmetrically. Some may align with a rotational axis, while others might precess. Such structured emissions are rare in natural comets. They resemble the behavior of a rotating body outfitted with fixed nozzles or vents, akin to exhaust patterns emitted by machinery with multiple ports. This is once again not based on desire for it to be technological, but rather because the geometry aligns with that of intentional systems. Nature must be definitively ruled out with evidence, and this new image weakens the natural explanation. The closer 3I Atlas approaches the sun, the more intense the solar wind becomes, which provides us with a natural experiment. For a comet, the solar wind should blow jets outward, causing tails to curve away. However, in the case of 3I Atlas, several jets resist bending. Some penetrate the solar wind, while others create luminous bow shocks, and the comet's shape remains stable. This suggests that the jets possess exceptionally high momentum, with heavier particles than water vapor and a heightened ionization state. There could even be electromagnetic coupling, leading us to a critical question. Is 3I Atlas interacting with the sun as a comet would, or as a charged object? Charged objects experience forces that ordinary dust and ice do not. If 3I Atlas is indeed metallic, the solar wind could create currents that generate magnetic fields, leading to Lorentz forces that might alter its path, accelerate it, or help produce jets. This is the scientific direction we are pursuing now. December 19 will mark the closest approach to Earth, and by that time, we will determine whether 3I Atlas fragmented or remained whole. Will the jets persist or diminish? Will the trajectory continue deviating from a gravitational path? Will the blue-green hue intensify? Will we spot precursor fragments near Earth or Mars? The jet image from November 11 is merely a prologue. It suggests that the object is entering a pivotal stage and confirms that the narrative is far from complete. We must remain alert, and as I often remind others, the universe does not owe us answers but rewards those who are attentive. In my Q&A, I concluded with a simple reminder: extraordinary claims necessitate extraordinary evidence. However, dismissing extraordinary evidence simply because it feels unsettling is not the ethos of science. The latest jet image captured on November 11 does not definitively prove that 3I Atlas is of technological origin, nor does it substantiate a natural explanation either. What it establishes is that we are observing something unprecedented, intricate, dynamic, and highly educational. Regardless of whether 3I Atlas is a fragmented comet, a metallic remnant, an ancient crystalline fragment, or an engineered design, it is imparting lessons to us: humility, curiosity, and the importance of reevaluating our perspectives, because at times, a single photograph can upend a century's worth of assumptions. This image, the jet portrait from November 11, may indeed be one of those transformative moments. As I advise my students, when confronted with phenomena that the universe has not prepared you for, do not shy away, because that is when science truly begins.